Right, we're going to look at dividing fractions and mixed numbers. This is level 3, so I'm going to teach you how to do it. And level 4 will be word problems, so you're going to have to look at a problem and decide if you can, you're going to have to divide numbers in and decide which numbers have to be divided and so on. Kind of similar to how we did multiplication. So first of all, let's have a look at how does it work. Well, let's think about what it means. Imagine with real numbers, with normal numbers, non-fractions, right? Imagine you have, say for example, 6 divided by 2. Well, what does that mean? That means how many 2's are needed to make 6, or how many 2's go into 6? We know that the answer is 3. Okay? So we're going to use that same logic when we're doing fractions. So for example, if you have 3 divided by a quarter, what that's asking is, how many quarters make up 3 whole units? And if you think about it like this, I always think about it in terms of pizzas. So if you have one pizza divided into quarters, you have 2 pizzas divided into quarters, and a third one. Well, if you look, one of these little areas here that I've shaded in red, one of them is a quarter of a pizza. And how many quarters does it take to make up 3 pizzas? Well, we have 1, 2, 3, 4 to make up 1. Okay, you see 1, 2, 3, 4 quarters makes up 1 full pizza. So to make up 3 full pizzas, it's 12. Okay, so we know that the answer to that is 12. So the answer is 12. Alright? And if you notice, that's the same as multiplying 3 by 4. Let's have a look at another quick example like that. If you have, say, 6 divided by 1/3. Well, the principle is the same. How many thirds do we need to make up 6? Well, 3/3 makes up 1 whole thing, so to make up 6 whole things, you need 18 thirds. Okay? So what the process is called for dividing fractions, we call it keep, change, flip. So here's what you do. Say, for example, we're doing 6 divided by 1/3 like this one here. Okay, the 6, we keep it. The sign, we change it to a multiplication. And the fraction, we flip it. Or sorry, the last fraction, or whatever it happens to be, we flip. Okay, and then we multiply like normal. Alright, so remember we said that 6 times 3 over 1 is 6 times 3, or we could write it as 6 over 1 times 3 over 1, and it works out to be 18. Okay, so for dividing fractions, what you do is keep, change, flip. Okay, so again, if we have a half divided by a quarter, if you think about that, how many quarters make up a half? That's the question that this is asking. Well, we know that 2 quarters is a half. 2 over 4 is a half, right? So we would expect our answer to this to be 2. So what we can do our keep, change, flip. Okay, and now you just multiply them. So we do our cross cancellation. 2 goes into 2 once, 2 goes into 4 twice. 1 and 1 stay the same, becomes 2 over 1, which is 2. Okay, so the process that we do is keep, change, flip. The first number, we keep it as it is. We change the multiplication to a division, the division to a multiplication, and then we flip the last fraction. So let's have a look at a couple of examples. So if you have this one here, simple one to start. Okay, so we have 3 over 7 divided by 2 over 9. So what we do is keep, change, flip. Alright, now let's look at the diagonals. First of all, 3 over 7 is simplified. This is fraction in its simplest form. 9 over 2 is 4.5, but we can leave it as 9 over 2 for this question. Now, diagonals, 3 and 2 can't be simplified, 7 and 9 can't be simplified, so we multiply, we get 27 over 14. And then to write our answer, when we get our answer, we always want our answers back as mixed numbers. So how many 14s make up 27? 1. And there's 13 left over. 1 and 13 14ths is your answer. So this is a fraction with a whole number, a fraction divided by a whole number. Now this seems a bit weird. How many 5's make up 3/5? How many 5s? Well, obviously 1 5 is 5, so it's not going to be a number, it's going to be a fraction of a 5. Okay? It's going to be a fraction of a 5 is needed to make up 3/5. So our answer here is going to be some kind of a fraction. So we do keep, change, and what we do is we flip the 5. We imagine that 5 here is 5 over 1, so we're going to flip it to get its reciprocal, which is 1 over 5. Okay? And we multiply. 3 times 1 is 3, 5 times 5 is 25, so 3/25. It takes 3/25 of a 5 to make up 3/5. Don't even worry about that if that doesn't make sense to you. Just worry about how the process works. Okay? Next one, now we have a whole number divided by a fraction instead of a fraction divided by a whole number. So we're going to do keep. I'm going to write 7 as 7 over 1. Change, flip. Okay. 7 over 1 and 5 over 4 can't be simplified. Diagonals, nothing to cross cancel. 7 and 4 no, 1 and 5 no, so it becomes 35 over 4. And we want to write that as a mixed number. It goes in 8 3/4 times. Okay? Finally, we have 2 mixed numbers. So we need to write both of them as improper fractions. So we get 6 times 2 is 12 plus 5 is 17 over 6. So first, I'm not going to do the keep, change, flip yet. One step at a time. First step, convert the two of them into improper fractions. 12 times 1 is 12 plus 11 is 23, so 23 over 12. So now I've written this expression, the question, as a division, but just now we have improper fractions. Now we do keep, change, flip. 17 over 6, the first fraction stays the same. The sign changes, and we get 12 over 17. Sorry, 12 over 23, that should be, I'll change that. 12 over 23. Now, let's look at the diagonals, see what we can do. 17 and 23 can't be, nothing can be cross-cancelled or simplified. 6 and 12, yeah, 6 goes into 6 once, 6 goes into 12 twice. So on top we have 17 times 2, 34. 1 times 23 is 23. So how many times does 23 go into 34? It goes in once, and 11 left over. And that's our answer. So that's how you do division of fractions. Like I said, the level 4, I'm not going to make a video, but it just will be word problems where it's testing that you can figure out what needs to be divided in where. And we'll go through some of them in class. And you'll see also that there's a worksheet on Moodle with these type of questions on it.